Okay, so 86. The base of a solid is the region in the first quadrant bounded by the y-axis, the graph of y equals inverse tangent, the horizontal line y equals 3, and the vertical line x equals 1. For this solid, each cross-section perpendicular to the x-axis is a square. What is the volume of the solid? All right, so this is the calculator okay section, but basically we have y equals 3, x equals 1, and then we have the inverse tangent looks like this, and here is x equals 1, and the region that we want is here, and the cross sections are squares with like with one side in here. Ugh, it froze. Okay, with one side in there. Okay, so what is the length of the cross section there? What is that red line in here? 3 minus inverse tangent of x. Exactly. So it's 3 minus, I'm sorry, I'm doing this with the mouse until I reset. Inverse tangent of x. Okay? And that's what you have to integrate. But what's the area then? What's the area of the square?
3 minus 10.
Inverse tangent of x squared, right? So that quantity squared is the area of that square, and then you have to find the integral of that. So area is this squared, so volume is that squared dx from 0 to 1, and it's b.
So when do we use,
The pi?
The pi is when it's
revolved. Yep. Okay, other questions? Yes, Ella. Which one? 87. The function has a first derivative, f prime, given by this. What is the coordinate of the inflection point of the graph of f? So basically, it's where is f prime of x equal to 0? Where does f prime of x cross, I'm sorry, f double prime of x cross the x-axis? Okay? And for this, to graph this, what you're going to do is you're just going to graph d dx of that. So you just go into your calculator, and you're just going to type in d dx. It's so awkward with this. d dx of that function. Okay? So you just type that function into your graph like this, into here. You graph it and you see where it crosses the x-axis.
Like the 0?
Yeah. You find the 0 of that.
So could we graph the first derivative and then just look?
Yeah.
Like at the maximum and minimum, because that would equal 0?
Yeah. No, not the, oh. I guess you could do that too. Yeah. It is B. Okay. Okay, so just graph this one. Any other questions? Okay, so it's over there. Okay, other questions? Yeah. Which one? 88. Okay, 88 was on one of your practice tests. Yes, it was. It was on one of your practice tests. So take a look at what this is asking you for. On this closed interval, which of the following could be the graph of a function f with the property that that is equal to 1? Okay, so what the heck is this? Okay, so this is f. What is this quantity that I highlighted? Conceptually, what is that? That's an integral, but it's the area under the graph of f from 2 to 4. Okay? So then what is this telling you? It's telling you 1/2 of that area is 1. So how much is the area?
2.
2, right? So now you have to look at these and you have to see for which one is the graph under the curve equal to 2. Is it that one? Is it that one? Is it this one? This one? This one? Right? Well, this is the only one where the area is equal to 2. So half of the area is equal to 1.
Can you even really figure out like
No.
A and B?
Nope.
Okay.
Not without the function.
That was the one
I mean,
function.
you can like estimate,
Like I
but
knew that it was C, but
right.
A and B, like I couldn't.
Mhm.
Okay.
Others?
77.
77. Okay. So the regions A, B, C are bounded by the graph of the function f and the x-axis. If the area of each region is 2, what is the value of -3 to 3 f of x plus 1? Okay, so what does f of x plus 1 mean? Like in reference to the actual function f of x. What happened to it? It like moves up, right? Okay, so here's what we're going to do. You can rewrite this as -3 to 3 f of x dx plus separated -3 to 3 1 dx. Okay, this is the area of the function as it stands now. So this is -2, +2, -2. This is 1 times 3 plus 3, 6. Okay, so at the end of the day, that's an 8, right? No, 4, C. Okay, all right, I'll take one more and then we'll move on.
But why is that? Why is 1 times 3 plus 3? Oh, because of a constant.
Yep. Okay, any others? Remember, the solutions to these are online, like the worked out
Where'd you
solution.
get the 3 plus 3 from?
So it's the integral of a constant. And remember when we had the integral of a constant, it's that number times upper minus lower.
Oh.
You remember? And because it's like y equals 1,
Oh, so then it's
and you're going from -3 to 3. So it's like 6 times 1. Okay. All right. Okay, let's go to the 2018. So people enter, this is a calculator question. People enter a line for an escalator at a rate modeled by the function r given by this. And again, this is 2018 number 1. So this is the rate at which people enter the escalator. R of t is measured in people per second. T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 per second. There are 20 people in line at time t equals 0. All right. So how many people enter the line for the escalator during the interval 0 to 300? So this is the rate of people. And here you want the amount of people. That is an integral, right? So you're just going to do from 0 to 300 r of t dt, okay? And that equals to 270, so it's that many people. Okay, that many people have entered will enter the escalator in the first 300 seconds. Okay, this is all you need to show, and you have to just plug it into your calculator as an integral. Okay, what I would do is I would plug r of t into f1 and then just do the integral from 0 to 300 of f1 because later on you might need the function again, which you will. Okay, during the time interval 0 to 300, there are always people in line for the escalator. How many people are in line at time 0 to 300? Okay, so how many people are in line at time 300? So this is like the final amount, okay, the final amount of people. So for part B, okay, it's 20. Okay, so there were 20 people when this problem started, plus, yep, that's the initial, plus this is the number of people that entered the escalator. Okay, this is the number of people that enter. This is the rate at which people are entering the escalator, but also people are leaving the line, right? People are leaving the line at what rate? 0.7. So it's minus 0.7 dt. So let's think about that. R is the rate of people entering. 0.7 is the rate of people leaving. The rate of the people in line is the rate entering minus the rate leaving. So R of t minus 0.7. Okay? And that will be 80.
Total 80.
Yeah, 80 people are in line at time 300.
Are they like if you put in your are they even numbers?
This one is, yeah.
Come on.
Well, no. No, I don't think you come up with even numbers. You have to round to the number of people.
You can't have that.
Huh? Yeah.
You round up or down?
I'll be down.
I would go down. Yeah.
You'd go down?
Yeah. Okay, for t is greater than 300, what is the first time t that there are no people in the escalator? Okay. Well, so based on this, at time 300, so this is for a time greater than 300. So look at what's happening here. Past 300 seconds, no one's getting on the no one's getting in line anymore. At 300 seconds, apparently there were 80 people still in line. And now, the first time that there are no people in line is when that last person leaves. So, if there are 80 people in line and they're leaving at a rate of 0.7 person per second, how do we know when this is all going to finish?
Minus the integral 0.7.
Well, it doesn't even have to be an integral because it's just a rate, right? Rate divided by so C, there are 80 people in line. Okay, they leave at a rate of 0.7 person per second. Okay? So, how long is it going to take for them to leave? So time is going to be the amount divided by the rate. Right? So, if there were 80 people and they were leaving at like 2 people per second, right? That would take 40 seconds, right? Because you divide. If it's 0.7 per second, it's that many. So this is, how much is that? Did you do it? It's,
what t equals?
yeah, 114. 0.286, yes. Okay? So what is the question saying? What is the first, for t is greater than 300, what is the first time t that there are no people in line? So it's 114 seconds after the 300 have passed, right? So it's 300 plus 114.286, which is 414.286 seconds. Okay.
I don't get why you divided it by the rate. Like that's just what you do.
Yeah, so if you have like distance equals rate times time, right? So okay, so how would you figure out what time, like how would you solve for time? It's d over r.
Yeah.
So it's the same sort of thing. So imagine, like I said, there are 80 people and they're leaving, 2 people are leaving
Oh, so
per second.
if you did like 80 equals RT.
Yes,
like
exactly.
time.
Yep. Yep.
But what would 80? What is 80 equal?
80 is the number of, 80 is like
Like
the
the people
distance.
in line.
Yeah, it's like the people in line now. Yep. Okay, so D, for time between 0 and 300, at what time T is the number of people in line at a minimum? To the nearest whole number, find the number of people in line at this time, justify your answer. Okay. We want to find the minimum of something in a closed interval. Minimum in a closed interval is EVT. Okay? Now we just need to figure out what it is that we're finding the minimum of. And we're finding the minimum of the number of people in line. So I'm just going to erase some of this because I need some space here. The number of people in line is 20 plus the integral of r, right? So from 0 to t, r of x dx, okay, minus 0.7 t, okay? So the number of people in line is, you had 20 people before, here is how many people came in, minus 0.7 of, however many minutes has passed, okay? So 20 plus the number of people that are coming in, minus the number of people that are leaving.
Why aren't we putting the 0.7 like in feet?
What we need, however, is the derivative of the number of people in line, okay? So what would that be? If you take a derivative of that, what would you get? Yeah, so if you take a derivative of this, you get 0 for the 20, right? And what does this give you? R of t minus 0.7, you want it to be equal to 0. Okay, so the derivative of that is this. And so this happens when r of t is equal to 0.7. So, and if you look on your calculator, like if you've graphed it, this happens at t equals 33.013 and 166.575. Yeah, seconds.
I'm confused, like the first part, like how you like the number of people in line.
Okay, so this is the number of people in the line. You know what? I'm gonna call this P, huh?
Yeah, like what is that?
Okay.
0 to t.
Okay, so this is the rate of people entering. When you take an integral, it's the number of people in line. Okay? But if you want to leave it, like if you don't want to do it make it a definite integral, if you want to leave it as an expression, then you got to go from 0 to a general time t.
Like why did you do that?
Because you want to find this for all time t, not just from 0 to 300 or from 0 to 20 seconds. This is an expression for any general time. So at any given time, it's The number of people are 0 to that time, the rate.
But it says from 0 to 300.
We need to now evaluate this expression P. We need to evaluate this expression P for the endpoints and the critical points. So P, what's an endpoint at 0? Is 20 plus 0 to 0 r of x dx minus 0.7 times 0, that's 0. Okay? Oh no, I'm sorry, that's 20. Then you want to do that for P of 33.013, P of 166.575, and P of 300. Okay? So, for each of these, you have to put this in your calculator like this, entering this number in for T. All right?
Into the whole,
Yeah, into that highlighted part.
But is r of x dx still this?
Yeah. R of x dx is still that. So this is going to be 3.803, 158.070. What's the number of people in line at 300? 80.
So we don't have to rewrite.
So you don't have to redo that one. And we want the minimum, which is this one. This is the minimum. So minimum, what is the question? How is the question worded? To the nearest whole number, find the number of people in line at this time. So the number, so there are nearest whole number. Nearest whole number is there are 4 people in line. Okay, so minimum 4 people in line at t equals 32.013 seconds. Yeah. The justification is, so what they want to see, they want to see that you do this. They want to see that you identify this as a point. They want to see that you did the EVT, and then the answer is 1 point. Okay. Huh? Yeah, 4-point problem. Yep. This one is 1 point. This one is 2, and the other one was 2 as well. Okay, let's do one more, and I think we'll call it a day. Okay, so a particle moves along the x-axis with a velocity given by this for 0 to 3.5. The particle is at position x equals -5 at t equals 0. So this is velocity, this is position, so x of x at 0 is -5. Find the acceleration of the particle at t equals 3. So the first thing you want to do here is graph this one. So tab what is the function here? So it's 10 sine 0.4 t squared over x squared minus x plus 3. Okay, so it looks like that, but we're only looking from 0 to 3.5. So if you like, you can go to menu, window settings, and you can put this from 0 to 3.5. Okay? Now, we want the acceleration at t equals 3. The acceleration is a of 3 is equal to v prime of 3, and this is the calculator section, so this is all you need to write, and it is -2.118.
Do Do you do the thing where you take the dy dx?
Yeah, so we go here. Yeah, so you can go menu, analyze graph, dy dx, 3, negative 2.118.
Don's so good at that.
What?
Don, like,
You guys are, yeah.
yeah, like I
We don't need
Yeah,
units,
Don-
right?
I know
Yeah.
how to do that.
Huh?
We don't need units, right?
So it doesn't say to give units, so no, then they only awarded 1 point for the answer for this. Okay, find the position of the particle at t equals 3. Well, this one is final position, right? So x of 3 is equal to x of 0 plus the integral from 0 to 3 v of t dt.
This one's kind of easy.
I know.
And there was one just like this on 29th year.
Exactly. See, this is what I mean when I say you're going to see the
We
patterns.
did this like
Like
on
with the
test.
calculator, this one's like breezy. You know?
Yeah.
At least A and B so far.
Once you see the way that they actually
Uh-huh.
word it and you know what they're trying to ask you, you totally get it.
This is
The
what I'm
pattern,
talking
the
about.
pattern.
This is what I'm talking about, okay? The more you do these, the more you'll see a pattern. And on each year's test, there's one of these. There's one rate. There's one slope field. There's one, so it's like, okay, so you have to write x of 3 equals, you have to write this purple one in some form, right? The negative 5 plus the integral. That's all you need to write. Everything else is on the calculator, and you get negative 1.760. So you were given 1 point for this, 1 point for the integral, 1 point for the answer. Okay?
That's
Yep.
cash. First two are cash.
Okay. Evaluate 0 to 3.5 v of t dt. Oh my god, that's like a plug and chug. We can do that. So literally just plug it into your calculator and you should get 2.844.
That's the point.
Well, it's a point with this one. 0 to 3.5 v of t, absolute value v of t dt. 3.737. Now comes the good part.
Oh, we gotta like justify our result.
Interpret the meaning of each integral in the context of this problem. So you say this, write it out. Okay? What is this? Displacement.
Did you purposely do the one with the 3, not the 3.5?
Oh, no. I was just too eager to continue. Displacement of the particle during the interval or over the interval 0 to 3.5. You can write it in any notation.
But you could do like 0 to 3.5.
Like 0 to 2?
Yeah.
I mean,
No.
I mean, maybe, but I don't like it. I personally.
Not any notation.
So not any notation, you got it.
That's not even notation. That's like a sentence.
What about like this? Like 0 with a little hyphen in the middle. 0 to 3.5.
So what would be another way
Yeah,
of
what's the
notating?
other
What would be
Okay.
another notation?
Oh my god. Oh, okay, so you're right. I do. Okay, like this.
Oh.
I'm not thinking.
Yeah, no.
I was not thinking.
Any acceptable.
two
So
notations.
yeah, set builder or
I'll just use
interval
I'll just use the
notation.
I go old fashioned.
0 to 3.5 absolute value v of t dt is the total distance traveled by the particle. Over 0 to 3.5 in this notation. All right. A second particle. There's always a second particle. You know what they say? Where there's one, there's another. A second particle moves along the x-axis with position given by x2 of t in the same time. Wouldn't you know that? At what time t are the two particles moving with the same velocity? Huh? Can you do that?
You do that.
Can you do that? How would you do that?
You gotta find the derivative
Yep. Find the derivative.
of this one and set it equal to the other one.
Okay. Okay. All right. So, okay. Good. Good. So, you have to find the derivative of this because then that would give you v2 of t, right? And then set it equal to the original v. So, v2 of t is x prime 2 of t, which is what? 2t minus 1. And now you want 2t minus 1 to equal the original v of t. Okay? So the way in which you do that is you go on your calculator. In F2, you just type in 2x minus 1, menu, analyze graph. Yes. Yes. 1.5. Okay. So t equals 1.571. So, this is 1 point, this is 1 point, and this is another point. So instead of you can also combine these two lines because this is the calculator section, and you can just say v of t is equal to x prime 2 of t. Okay, like without explicitly showing what the derivative is, that would have been an okay step because it's the calculator section, and then this.
Or if we did v2 of t equals x prime 2 of t equals 2t minus 1, then under that could we write like v2 of t equals v of t? Does that make sense? Or is that what
You can do that.
Okay.
Yep, you can do that. Okay, so for the next FRQ in-class quiz, it's 5 and 6 of 2019, 1 and 2 of 2018, so a lot less.